Good evening. Let us start today's lecture. Exercise 7.3, first part, third sum. Actually, this is for homework. The answer is -1. We'll be doing fourth one. Let L be the limit. Limit extends to 2. Root of 2 plus x minus root of 6 minus x upon root x minus root 2. Can we take limit in the first step? No. We get 0 by 0 form. Here you will notice that both numerator and denominator are irrational. So we are supposed to rationalize numerator and denominator both. I repeat, here we have to rationalize both numerator and denominator. This is rationalizing factor of numerator and this is rationalizing factor of denominator. Please remember, though we say rationalizing numerator, we have to multiply denominator also by that rationalizing factor. Otherwise function will change. Then why to say rationalizing numerator? For the simple reason, it is rationalizing factor of numerator. Okay. Now next step, what is the product of first and second in numerator? A minus b into a plus b is a square minus b square. You have to be careful while opening the bracket. So 2 plus x minus 6 plus x. What about this? As it is. In the denominator, take product of first and third terms. So it is x minus 2. This as it is. Right now. So this is actually 2x minus 4. Take 2 common to get x minus 2. Yes, we are looking for this factor only because x minus 2 is giving 0 by 0 form. So cancel that. Why can we cancel? Because x only tends to 2. X is not 2. Now after cancelling this, mention remaining terms, then take the limit. To take the limit means to replace every x by its limiting value. Simplify to get final answer as root 2. Second first part, just listen to me. Of course, you are supposed to write the solution after the lecture. Limit extends to a root of a plus 2x minus root 3x upon root of 3a plus x minus 2 root x. Same logic, rationalize numerator and denominator both. In the numerator, take product of first and second. So it is a plus 2x minus 3x, right? This as it is. In the denominator, take product of first and third because this is the rationalizing factor of denominator, this one. So 3a plus x minus, what is square of 2 root x? 4x. That is why minus 4x. This as it is. Next step. A plus 2x minus 3x is a minus x. Okay. This as it is. What about denominator? 3a plus x minus 4x. It is actually 3a minus 3x. Take 3 common to get a minus x. Yes, we were looking for a minus x only because this is giving 0 by 0 form. So cancel that. Then take the limit. To take the limit means to replace every x by its limiting value. So if you do so, then you get final answer as 2 upon 3 root 3. Sum number 3, let L be the limit. Limit extends to 2 root of 1 plus root of 2 plus x minus root 3 upon x minus 2. Can we take limit in the first step? No, 0 by 0 form. So we rationalize numerator. That is multiply numerator and denominator by root of 1 plus root of 2 plus x plus root 3. See the next step. Actually, for this part, see the cursor. For this part, limit can be evaluated, but not in this step. This is not allowed that you are putting x equal to 2 here without taking limit. So we have to write one more step. Now you may ask, sir, can we keep this as it is and at the end we will take the limit? Yes, that is also correct. But here I have used the result. Limit of product is product of limits. So limit of this into. Now a minus b into a plus b is a square minus b square. So 1 plus root of 2 plus x minus 3 means what? Root of 2 plus x minus 2. Again, you have to rationalize the numerator. Now, what about this? I will evaluate this limit. To take the limit means to replace every x by its limiting part, or rather limiting value, which in this case is 2. Right now. So, I have written limit of product of limits. For the first part, limit can be taken by putting x equal to 2. 2 plus 2, 4. Root 4 is 2. And that is why it is root of 1 plus 2, that is root 3 plus root 3. Here, again, you have to rationalize numerator. So on rationalizing, we get 2 plus x minus 4, that is x minus 2. Now, the next step is simple one. Cancel x minus 2. Why can we do that? Because x only tends to 2. X is not equal to 2. So division by x minus 2 is valid. And then take the limit. So it is 1 upon 2 root 3. Put x equal to 2. On simplification, you get final answer as 1 upon 8 root 3. Now the fourth is for homework. Answer is 1 upon 2a. Sum number 5. Let me explain first. Limit extends to 0. Root x square plus 9 minus root of 2x square plus 9 upon root of 3x square plus 4 minus root of 2x square plus 4. Clearly, we have to rationalize both numerator and denominator. Now in the numerator, we have to take product of first and second. A minus b into a plus b is a square minus b square. So x square plus 9 minus in bracket 2x square plus 9. This as it is. In the denominator, we have to take product of first and third. So 3x square plus 4 less in bracket 2x square plus 4. This factor as it is. Now open the bracket, x square plus 9 minus 2x square minus 9. So just minus x square. And here only x square. Yes, we were looking for this factor only because it is giving 0 by 0 form. So cancel that. Once you cancel it, take the limit. To take the limit means to replace every x by its limiting value. See, all the steps are mentioned. In fact, you need not write this step in exam. They have used the theorem that limit of quotient is limit of numerator upon limit of denominator. If limit of denominator is not equal to 0, you can directly take the limit, right? So what is the final answer? Final answer is minus 2 upon 3. Third sum, first part. Let L be the limit. Limit extends to 1. X square plus x root x minus 2 upon x minus 1. See, we write this minus 2 as minus 1 minus 1. So the next step is x square minus 1 plus x root x minus 1. So we have written the same numerator, and of course we have to write the same, but we have written that in different form, which is allowed. Now why to write in this manner? Because if you split numerator, then you will notice that standard limit can be used. Actually, I have omitted one step. First, you have to split numerator and then you have to say limit of sum is sum of limits. Now here I will write this 1 as 1 square. What is x root x? X raised to 3 by 2. Can I write 1 as 1 raised to 3 by 2? Yes, I can. So we have to use limit extends to a x raised to n minus a raised to n upon x minus a as n into a raised to n minus 1. So this is 2 into 1 raised to, that is 1, plus 3 by 2 into 1 raised to is, that part is again 1. So 2 plus 3 by 2, that is 7 by 2 is the answer. Second, let me explain. Limit extends to 0. Root 1 plus x square minus root 1 plus x upon root 1 plus x cube minus root 1 plus x. Again, same logic. You have to rationalize both numerator and denominator. So that gives me numerator as x square minus x into this as it is. What about denominator? X cube minus x. Now, from these two terms, take x common to get x minus 1. From these two terms, take x common to get x square minus 1. Now, can we cancel x? Yes, in fact, we were looking for this factor only. This is responsible for giving 0 by 0 form. Once you cancel it, take the limit. Now, you may ask me, sir, can we factorize x square minus 1? Yes, you can. But why to factorize? So to take the limit means to replace every x by its limiting value, which in this case is 0. So what is the final answer? It is 1. Okay, now I haven't written all the steps. You should realize that you have to rationalize both numerator and denominator. Uh, you get minus z minus 4 in the denominator, I'm sorry, numerator, and z minus 4 in the denominator. Cancel that. On cancelling it, we get this one. Take the limit. To take the limit means to replace every z by its limiting value. So minus into in bracket 1 plus what is root of 5 minus 4? That is root 1, 1. 3 plus root of 5 plus 4, 9, root 9, 3. So minus 1 upon 3 is the answer for sum number 4. Write down. Sum number 5, limit x tends to 0. 3 upon x root 9 minus x minus 1 upon x. What is LCM? X root 9 minus x. What is numerator? 3 minus root 9 minus x. Now you have to rationalize numerator. So numerator is of which type now? A minus b, a plus b, which is a square minus b square. So 9 minus in bracket 9 minus x. So it is simply x. Denominator as it is. Now in the next step, cancel x. Why can we cancel x? Because x only tends to 0. X is not equal to 0. So if you take the limit, of course, before taking limit, you have to write the remaining factors and then first check whether denominator is 0 on taking limit. No, it is not. So we are in a position to take the limit. To take the limit means to replace every x by its limiting value, which in this case is 0. So on simplification, 1 upon 18 is the final answer. Now the next important part is limit of trigonometric function. We are going to discuss standard trigonometric limit. In today's lecture, we will just verify this result, and in the next lecture, we will actually prove this standard limit. Now the standard trigo limit is limit x tends to 0 sin x upon x equal to 1. I repeat, limit x tends to 0 sin x upon x equal to 1. Note that this angle x must be in radian only. If it is in degree, you have to convert it into radian. So angle is in radian. You will notice that angle in the numerator is fully repeated in the denominator, and this angle, most important condition, angle is very small, it tends to 0. So in physics, you must have considered that for very small angle, of course in radian, sin x can approximately taken as x. Sin x upon x is approximately 1. So sin x is approximately equal to x, right? So the main criterion, angle must be in radian, then angle should tend to 0, and last part, angle in the numerator is fully repeated in the denominator. I repeat, limit x tends to 0, sin x upon x equal to 1, angle is in radian, angle tends to 0, and angle in the numerator is fully repeated in the denominator. Now this is how we can verify this result. I consider angle as pi by 10, sin pi by 10 upon pi by 10. What is pi by 10? 18 degree, angle pi by 10. So sin 18 degrees is this. You can find it using natural sine table, log tables. Pi is 3.14. I have taken pi as 3.14 upon 10 is 0.314. Yes, numerator is almost same as denominator. Now I consider smaller angle, say pi by 20. So in that case, sin pi by 20 is 0.1564. Denominator is 0.157. Again smaller one, pi by 100, that is 1.8 degree. Sine of 1.8 degree is 0.0314. 3.14 upon 100 is 0.314. This is the ratio of unity, right? So as we consider angle in radian, smaller and smaller, and it approaches 0, then we get this result. Limit x tends to 0, sin x upon x equal to 1. I think in the textbook they have used the variable theta, but variable is immaterial. You can say limit theta tends to 0, sine theta upon theta equal to 1. Let us find limit x tends to 0 tan x upon x. Now what is tan x? Sin x upon cos x. So I write this as sin x upon x into 1 upon cos x. What is limit of product? Product of limits. Now this is standard limit. Here you have to replace every x by limiting value which is 0. What is cos 0? 1. So final answer is 1. Previously we used to say to take the limit means to replace every x by its limiting value. Now we will say to take the limit means either to use standard trigonometric limit or replace every x by its limiting value. So limit x tends to 0, tan x upon x is always 1. Actually, you can verify this by considering very small angle. Tell me, what is tan pi by 100? I think it is same as sin pi by 100. Tell me the numerator, I'll tell you the denominator. Denominator is 0.0314. I think numerator is also the same. 0.0314. Right. So this is not the proof. This is the verification. We have verified that if angle x is very small and in radian, then limit x tends to 0, tan x upon x is nothing but 1. Here exactly 1 because pi is not exactly 3.14, right? But we took pi as 3.14 only. Try to find limit x tends to 0 cos x upon x. See, as x tends to 0, cos x tends to 1 and denominator tends to 0. So the correct answer is does not exist. This limit does not exist. Okay. Now these three results, we already proved the first one. Limit x tends to 0, tan x upon x is 1. Now what is the value of this limit? Limit x tends to 0, sin mx upon mx, it is also 1. Why? Because all the three conditions are satisfied. Angle is in radian. Angle tends to 0. Because as x tends to 0, mx tends to m into 0, that is 0. Angle in the numerator is fully repeated in the denominator. What is m? M is real number not equal to 0, right? Same for tan also. Actually, these sums are not from the textbook. Just to understand the concept, we'll first solve simple sums. First one, limit x tends to 0, sin 7x upon x. I hope you won't cancel x and then we'll say that sin 7 is constant, so value of the limit is sin 7. That is ridiculous. Can we write value of this limit as 1? The answer is no. Though two conditions are satisfied, angle is in radian and angle tends to 0, but it is not fully repeated in the denominator. So first we repeat angle in the denominator. We write 7x, but original denominator is x. We cannot just multiply denominator by 7. We have to multiply numerator also by 7. Now limit of constant into function is that constant into limit of function. Now can I say value of this limit is 1? Yes, I can, provided I write the reason for this. Or you may actually write the substitution. In exam, it is not expected, but you are expected to write as x tends to 0, this angle 7x also tends to 0. And which standard limit is used? I have used the variable y. Why? Because I will not say put 7x equal to x. I will put a 7x equal to y only, or theta, any other variable than x, right? So y, this standard limit, and that is why final answer is 7. Right now. Second, limit x tends to 0, sin 11x by 3 upon 13x. Now first we write what we want. We want that angle must be fully repeated. So though denominator is 13x, I write it as 11x by 3. I have multiplied denominator by 11 by 3. So I multiply numerator also by the same. But original denominator is not x, it is 13x. So into 1 by 13. In the next step, take this constant part 11 upon 3 into 13, 39. So 11 by 39 outside the limit. Now can I say value of this limit is 1? Yes, I can. Angle is in radian. angle tends to 0 and is fully repeated in the denominator. Value of this limit is 1. So 11 by 39 is the final answer. You will get full marks provided you write this as x tends to 0. This angle tends to 0. And which standard limit? I repeat, use another variable, limit y tends to 0, sin y upon y equal to 1.